Hello and very good morning. So for today, I'm going to present about cloud-based encryption platform for Google Drive using post-quantum cryptography algorithm. So for introduction and program background, in the digital age, cloud computing technology like Google Drive offer unparalleled convenience for remote data storage and access. However, cybersecurity threat pose significant risk. Metomate 2023 Google Scanner report revealed that 40.2% of 6.5 million scanned Google Drive files contain sensitive data, making them susceptible to unauthorized access and data breaches. This vulnerability impacts user trust and raise concern about data integrity, confidentiality, and availability. The primary issue is the inadequacy of the encryption method to protect against sophisticated cyber attack and the emerging threat of quantum computing execution, while effective now, may not withstand future quantum attack. So the National Institute of Standard Technology, NIST in USA, is developing post-quantum encryption standard, anticipating quantum supremacy within the next decade, which will render current asymmetric regulation like RSA ineffective. So addressing this dependencies is crucial to avoid higher cost and increased security risk in the future. So we have open encryption, security data on platform like Google Drive will be vulnerable to cyber criminals. Next is the project aim. The project aim of the project is to create a cloud encryption system for Google Drive, which can be used to encrypt data stored in cloud and also to showcase the usage of post-quantum algorithm in the Google Drive encryption system. And the project objective is to study the current cloud-based encryption platform that is used for fast and existing post-quantum cryptography algorithm. And next is to design and develop a cloud-based encryption platform specifically for fast within the addition of integrating post-quantum cryptography algorithm to validate the result by conducting security performance testing. The scope of this project, the stakeholder in this project will be Google Drive, as the technology itself is Google Drive. And the safe drive will only cover basic functionality like file encryption, decryption, sequential of encrypted file in Google Drive. And safe drive will be implementing only post-quantum cryptography algorithm like ATI encrypt. And safe drive will involve research into encryption technique and cloud storage security system. It will require significant coding effort to develop the encryption algorithm, the user interface, and also the integration with the Google Drive API. So testing will be important to ensure the security and the functionality of the tool. And the targeted user for this project will be internet user who want to secure their fast and Google Drive, and mainly UTM students who are internet user mostly of them. And so for latest review, we're going to go first with the quantum computing. Quantum computing is utilizing phenomena like solution quantum entanglement by allowing quantum bits qubit to exist in multiple states simultaneously. It enables parallel computation and significantly faster processing for certain tasks compared to classical computer nowadays. This poses a substantial threat to traditional encryption algorithm like RSA and Diffie-Hellman, which rely on the difficulty of factoring large number as algorithm that shows can break this encryption very efficiently. So Grover's algorithm can halve the effective security of AES by halving it from maybe 256 into 128. So this vulnerability highlight the agency to have a post-quantum cryptography algorithm that can fight against this potential quantum attack. So PQC or post-quantum cryptography for long, focus on ensuring cryptographic security against quantum computing threat, preparing current system for quantum era. So for the type of PQC, I'm going to go to lattice-based cryptography, which uses multi-dimensional lattices to solve cryptographic problem. Example is entirely encrypt. Hash-based cryptography, ensure message integrity using hash function. Example is Merkle. Code-based cryptography, it utilizes error correcting code to create a secure encryption. Example is McAllister multivariate public key system or MPKC for short, relies on set of quadratic polynomial over finite fields for security. Example is HFE or hidden fee scheme. Lattice-based cryptography, there are about four. Lattice-based cryptography is the most promising one against the advent of quantum computing. So a lattice is a grid of regularly spaced point in a vector space. It represented by a basis of vector. This basis ensure unique lattice representation, crucial for cryptographic application where security relies on solving complexity problem. This is what for. Shortest vector problem is finding the shortest non-zero vector in a lattice. It's very challenging. All of that is very challenging for quantum computer. Closest vector problem is determine the lattice point closest to a given arbitrary point. Let's say LWE or learning with error, it hides secret information by introducing error into the equation, making the equation substantially more difficult. And shortest independent problem six a set of short linearly independent vector within a lattice. Cloud computing, which is what you're focusing on here, is widely adopted because it's very scalable and also accessible to all people, regardless of income level or uh, access to resources. Security in cloud service like Google Drive and OneDrive is maintained through robust encryption methods such as AES and RDS to ensure data confidentiality, integrity, and availability, or CIA for short. This, despite this measure, concern persists regarding data control and privacy, leading to the adoption of client-side encryption tools like Cryptomator and Boxcryptor. This tool add an additional layer of security by ensuring that the encryption key remain under user control rather than within the cloud provider. Cryptomator, wonderful to focus on. It's an open source encryption software designed specifically for securing files stored in cloud storage services like Dropbox, Google Drive, and OneDrive. It utilizes ES encryption. It is client-side encryption. It is compatible with platforms like Windows, Mac OS, Linux, and Android OS. It is also open source, which allows transparency and community contribution to the code base, maybe making it more free and enhance the security itself. And the user interface is friendly and easy to use. And Box Creator is the competitor, I believe so. And it's developed by Secomba GmbH, and it is almost the same as Cryptomator, but it offers the enterprise solution where it offers solution tailored to business and enterprise user, providing additional feature like centralized management and compliance too. Post-quantum cryptography offer advanced security measure designed to withstand quantum computing threat. NTRU Encrypt, for example, employs a polymer-based encryption resistant to quantum attack and demonstrates superior performance compared to traditional cryptographic algorithm that we see today. As quantum computing capability advance, the adoption of PQC algorithm become increasingly critical to safeguard sensitive data against future threats. Security measure in Google Drive. Google Drive is a leading cloud service. It's also implement rigorous security measures to protect user data. For example, it has strong encryption for data into SARS, TLS for secure automation, robust authentication mechanism for two-factor authentication. Despite this effort, ongoing research focus on enhancing cloud security and respond to evolving threat and privacy consideration. Anti-encrypt for short is a robust example of post-quantum cryptography. Is leverage quality equation for encryption and decryption. And unlike the usual system, it incorporates probabilistic encryption, offering multiple encryption option per message for enhanced security and efficiency. First, I'm going to go through with the working with the key parameter to the NPQ array. The NQ must be defined for the system must be set up first. Then it involves key generation, where it involves setting small parameter FNG, finding the addresses, and generating a secret key and public key. Then add this and board in this case. Transform a message into a polymer M, the conversion module P, encrypt using small polymer R, and calculate ciphertext C. And the decryption board can decrypt the key using the receive ciphertext E using the secret key. This is the basis of anti-ID encrypt. And anti-encrypt demonstrates superior speed and performance as it is 4 times faster than RSA and 2 times faster than ACC. It resistant to quantum computer attack, other cryptographic technology makes it promising choice for future-proof encryption. For the system development, for me, I'm going to use Agile for this period because Agile is the best one in this case because it have the phases can help me to actually improve or create the software itself. First is the requirement phase. First, in the requirement phase, we have to study and define the project requirement, ensuring alignment with user need and security specification. The version is to read. Next is design phase, where we develop system architecture and user interface prototype to ensure functionality and usability. Next is development phase, implement safety effectively and sprint to meet functional requirement, focusing on agile principle. Duration is variable so, but for each two use case, it's about 2 weeks. And for testing phase, it will conduct comprehensive system and performance testing, where we test the system to see whether it's good or it really need much more improvement. And for deployment and review, we prepare safe drive for public release, including user acceptance testing to verify availability and versatility. Ongoing process post-deployment to address issue and issues with security compliance. And technology used for front end, we use HTML, CSS, JavaScript for creating interactive web interfaces. React to for framework for building UI component, backend tech, MySQL database management system, Python plus for backend development for server-side logic, Python library for implementing NTI encrypt, Google API, processor, Intel for i5 equivalent, memory 5 GB, 8 GB, 250 GB SSD for storage, graphic card is optional. And for the software, operating system need to be the latest, and web server is Python 3.7 plus, and then so on. And for the survey result, I have conducted a survey to see in UTM. So this is about 30 participants or 32 participants where I asked about their what's the most important feature they're looking for when they are using services like Google Drive, and also how familiar of them with the content computing that we hear now, and are they scared or are they concerned about it. And based on the survey, there are a few striking points that we've mentioned. First is majority want file creation and secure file sharing as primary feature they are focused on. Yes, it's a sizable majority of concern of the security of their files in Google Drive, which shown as about important, a majority vote for importance of sharing files securely. In terms of quantum computing and its threat, fortunately, the students have the awareness of quantum computing and put it immensely on the cloud encryption system with post-quantum cryptography. Based on the both functional requirement are created to fulfill the expectation of user information. The user requirement is user login, file encryption, store and manage key, share unlock key, and download and duplicate file. And the acceptance criteria for user login, user can be directed into safe drive without needing to create a new account. And so for file encryption, it's important that the file is encrypted with the entire encrypt and secure. And for the store and manage key, user want to securely store encryption key and password protected database. This allows safe and secure access to encrypted file. And share unlock key, when user want to share their key, they can share it by sending email, etc. And download and duplicate shared file. As a recipient, it's important to be able to download the encrypted file from Google Drive and decrypt using the encryption key sent via email. And this use case again, there are about 10 here. Is create file using shared key, log in using Google account, upload file, download file, encrypt file, decrypt file, share encryption key via email, generate encryption key, store encryption key, and retrieve encryption key. And for the system architecture design, for the user interface, that's a more comprehensive tool, including this part where the end part that the user can see. So they are login screen, this are loading, the loading file, the management of the encryption key for file, and the shared file. For the user interface is the way the user can see it. And safe application itself is for the actual logic application. It handle all the login, all the items, it's the back end, and it store file, etc. For Google Drive API, it help it link with the Google Drive integration, so we can use the Google Drive API component itself for the safe drive. And integration service is where we use the algorithm to encrypt and decrypt the file using encrypt in this case. And the key management is where we generate and we store and we retrieve the key of user, and the email is where we use the email to send the email to other people that want the key. And class diagram, once you user attribute, this file, which is service, attribute, NTI encrypt, Google API, key management, and email service. Data design, due to the simple nature of data, it only necessary to have database for managing user information and encryption key. Only could that access a database for the user and key management with information like the user ID connected with the ID. The key will be encrypted and stored. This helps in the provision of safe effective means of delegating and managing key. On the other hand, items like file attribute, encryption algorithm, and service configuration, Google API and the server are usually managed in memory or configuration file that does not require database storage. Yes, help to focus only on the core functionality of SafeGraph, making it more straightforward and avoid unnecessary complexity, making it more complicated to build. Next is the user interface. First is the login page for the SafeGraph, and next is the dashboard where you welcome user, and there's about for interface where user can choose and pick. As the button is big, and for the next is the upload file where user can upload the file, and then the download file where user can download and also recipient can download the file that is given. And so this is the manage encryption key where user can manage the encryption key that they have. And also the last one is send email where user can send email to the recipient itself so that they can get the key so that they can access the file. Okay, so that's all for me, and thank you for listening.